Morning, grade 7s. Unit 8, Statistics and Probability. Section 8.5, Independent Events and Sample Space. Can be found on pages 213 to 216 in the textbook, and it is the last lesson of Unit 8. Key vocabulary. Independent events. If two or more events were to happen, where what happens in one has no effect on what happens in the other. I'll explain this in the next slide and give examples. Sample space consists of all possible outcomes for each of the two independent events. Die means one dice. The things you roll and have 6 sides and 6 numbers. What are independent events? If two or more events were to happen, where what happens in one has no effect on what happens in the other, we call them independent events. They don't depend on each other. If we roll a die and flip a coin, the result for the die has no effect on the result for the coin. So these events are independent. If we draw 3 cards from a deck where we replace the first card and shuffle the deck before drawing the second card, then the events are independent. If we draw 2 cards from a deck where we do not replace the first card before drawing the second card, then these events are not independent. The card taken out of the deck does have an effect on the probability of what card will be drawn on the second draw. For example, you have 52 cards and I draw 1 card and I take it out and I don't put it back in, and then I go to draw another card, it's going to be out of 51 because originally it was 52. I took the card, I didn't put it back in. So this would mean they're not independent. What is a sample space? A sample space consists of all possible outcomes for each of the two independent events. To determine all possible outcomes, the sample space of two independent events, list all probabilities. A good way to do this is making a chart, making a table. Some people make a table or they just list them all. So list all possible outcomes of heads and tails when 2 coins are flipped. The first could be head and the second could be tail. The first could be a tail and the second could be a head, and both could be heads and both could be tails. So there is 4 possible outcomes with 2 coins, 4 possible outcomes. And if there's 3 coins, which we'll talk about, there will be even more possible outcomes. Probability of an independent event. The probability of an event is equal to the number of possible successes over the total number of possibilities. So, example, find the probability of flipping 2 heads when 2 coins are flipped. Using the sample space, look at the sample space above to determine the answer. It shows a total of 4 possible outcomes, one of which has 2 heads. So P, which is the probability of flipping of 2 heads, equals number of outcomes with 2 heads, which is 1, total number of outcomes, 4. And if I go back to the slide, you can see here there's 4 possible outcomes and there's only 1 with 2 heads. Using independent probabilities. If 2 probabilities A and B are independent, we can find the probability of both occurring by finding the product of each of the probabilities. So P equal P, A and B equals P, A times, that dot means times, PB. So flipping 2 heads equals, well, first a head times second a head, 1 half times 1 half equals 1/4. When you multiply fractions, you multiply the top and you multiply the bottom. 1 times 1 is 1, 2 times 2 is 4. There's a video, like I said before, you can open up the slides and watch the video. It's very helpful. This is the link. You can't click it here on the actual YouTube video, but go back to the math and open the files under online learning and you will find slides 8.5 and you can get this video. I think it's the 6th slide. Exercise number 1. List all possible outcomes, the sample space, for each pair of independent events. Over here, A and B, I did half of it, I did half of them for you, and I want you to continue and finish the question. So they want to know all the combinations of numbers and of heads and tails from throwing a die and a coin. So you're rolling 1 die with 6 sides and you're rolling a coin. So that means you have 6 sides on the die, so there's 6 possible outcomes. The coin has 2, so you're going to have altogether 12 possible outcomes. Over here, I have the first 6. H1 means heads, you get a head and you roll a 1. H2 means you get heads, you roll a 2. H3, same thing, you flip a heads and you roll a 3, and so on, so on, so on. So now you need to do it and continue this because this is not the total answer. You need to tell me the 6 other possible outcomes. And I'll give you a hint, it starts with T, and it looks very similar to that, what you have here. B, combination of numbers from throwing 2 dice. This is not actually, I wasn't able to make the proper table. The number is not actually 11. 1 means you roll a 1 and a 1. 21 doesn't mean 21, it means you roll a 2 and a 1. And so on and so on. So here I listed some of them. It's not fully done. Again, a die has 6 sides. So I'll give you a hint, you're missing 2 more rows. So finish that for B. Exercise number 2. What is the probability of randomly drawing the following from a deck of cards? Remember, each time a card is selected, it is replaced and the deck shuffled before the next draw. So it's independent, it's not dependent, you're putting back the card. Drawing a red card twice in a row. First of all, there's 1/2 and 1/2. The answer is going to equal 1/2 times 1/2 is 1/4. It's 1 out of 4 chance you will draw 2 red cards. Drawing a heart twice in a row. The probability of drawing a heart is 1 out of 4, which is 13 out of 52 times 1 out of 4. The answer is 1 out of 16. Drawing a face card and then drawing a 10. Okay, so face card, there is a 3 out of 13 chance. Drawing a 10, there's 1 out of 13. And these are simplified, the fractions, which equals 3 out of 169. Chance of drawing a 10. Drawing 2 queens in a row. There will be what? 1 out of 64 because there's a 1 out of 13 chance of getting a queen and another 1 out of 13 chance of getting another queen. So you multiply them, you get 1 out of 69. And drawing 3 black cards in a row is going to be 1 out of 8 because there's half of the cards are black, and then another half. If you multiply them, equals 1 out of 8 because 1 times 1 times 1 is 1, 2 times 2 times 2 is 8. And drawing 3 spades in a row would equal 1 out of 64 because there's a quarter chance of getting a spade times a quarter chance of getting another spade, and a third spade is 1 out of 4, which equals 1 out of 64. Exercise number 3. What is the theoretical probability of each of the following events occurring? Flipping exactly 2 heads with 2 coins. We already did that, and the answer is 1 out of 4. This was even earlier in the examples. Now it's different. Flipping exactly 2 heads with 3 coins. I'll give you a hint. Go to page 214, and you can figure out the answer. Selecting a number card, example 1 to 10, greater than 6 from a deck of cards and rolling a number less than 3 on a die. That probability is actually 4 out of 13, which is reduced, and times 1 out of 3 because there's 2 out of 6 chance, which is 1 out of 3 of rolling a number less than 3. The answer is 4 out of 39. And last question, selecting a heart from a deck of cards and rolling an odd number on a die, which is a heart has a 1/4 chance, rolling an odd number is 1/2 on a die. Answer is 1 out of 8. I want to send a shout out to Ms. Jolene for the amazing slides she's made. She made all these slides, and I wish you guys all the best of luck, and stay safe and wash your hands. The next 2, you're on your own, rolling 2 numbers which are the same with 2 dice, and rolling 2 odd numbers with a pair of dice. Good luck. Try these. Rolling 2 numbers which are the same with 2 dice. I would go back to number 1, exercise 1B. That's almost there. If you fill that out, you can actually figure out the answer, put it in simplest form. And F, rolling 2 odd numbers with a pair of dice. Again, go back to that question, exercise 1B, and you will be able to find the answer. Good luck.